Hello students, welcome to the Java class. In this video, we are going to see about the second implementation class of list, which is linked list. In a previous video, we have seen about array list. Now we are going to see about the linked list. So before seeing what is the linked list, so first we should see about the uses of collections. So first we should see what are the uses of collections. Uses of collections. So assume this is a collection and this collection has 5 objects S1, S2, S3, S4 and S5. So what is the main use of collection? The main use of a collection is to hold and transfer the objects from one location to the another location. So what is the main use of a collection? The main use of a collection is to hold and transfer the objects from one location to the another location. Say suppose I want to transfer these objects from my current location to the London location. So this is London. Assume that this is a London. Assume this is a London office. So what is the main use of a collection? The main use of a collection is to hold and transfer an objects from one location to the another location. So to hold and transfer these objects, the collection will implement an interface called as serializable. So why collection implements serializable? The collection implements serializable to hold and transfer the objects from one location to the another location. Say in the London, we got this collection. So what I will do is, I will call a clear method on this collection object. So what happens when I call a clear method on the collection object? When we call a clear method on a collection objects, the entire objects will be deleted and the collection will become empty. Say suppose I want to perform some operation on this S2 object. So is it possible to perform any operation on the S2 object? No, it is not possible. Why? Because I have deleted all the objects inside this collections. Now the collection is empty. So what is the possible solution? The possible solution is I can request for a retransmission of this entire collection. So what is the possible solution? I can request for the retransmission of this entire collection. So is this the recommended approach? No, this is not the recommended approach. Why? Because it takes more time for the retransmission of an collection objects. So what is the solution for this problem? The solution is by default. So by default, every collection interfaces implements clonable interface. By default, every collection interface implements clonable interface. So what is the use of this clonable interface? The use of this clonable interface is I can make a copy of this original collections. I can make a copy of a original collection, and if I want to perform any operations, I can make a operations on this copied collection. Okay. Next, if something goes wrong, so what I can do? I can make another copy. So this is the main advantage of clonable interface. So why collections are used? So usually we can use collections to hold and transfer objects from one locations to the another locations. So here collection is acting like a container. Okay. Next, so to provide support for this requirement, every collection interface implements what? To provide support for this requirement, every collection interface implements serializable and clonable interfaces. Is it clear? So why collection interfaces are used? So usually we can use collections to hold and transfer objects from one location to another location. So to provide support for this requirement, every collection class by default implements what? Serializable and clonable interfaces. Now consider this example. Assume this is an array list and this array list has 1 crore elements. Okay. Now my requirement is I want to access the first element. To access first element, how much time it will take? Assume it will take 1 nanoseconds. Next, I want to access the second element. To access second element, how much time it will take? It will take the same time, that is 1 nanoseconds. Now I want to access the 1000th element. To access 1000th element, how much time it will take? It will take the same time, that is 1 nanoseconds. Next, I want to access the 1 crore element. To access 1 crore element, how much time it will take? To access 1 crore element, it will take the same time, that is 1 nanoseconds. So, in an array list, to access any elements, it will take the same time. So, how this is possible? This is possible because an array list implements a interface called as random access interface. An array list implements an interface called as random access interface, due to which to access any elements, it will take the same time. Okay. In a collection concept, array list and vector class, only these two classes implements random access interface. Remember this. Array list and vector classes implements random access interface, so that any random element we can access with the same speed. Okay. Next, where this random access interface is defined? This random access interface is defined in java.util package. You can see here the random access interface is present in which package? It is present in java.util package and does not contain any methods. This interface does not contain any methods. The interface which does not contain any methods is called as marker interface. Okay. The interface which does not contain any method is called as marker interface. So, where we will get the required functionality? So, the required functionality will be automatically provided by the JVM. Is this clear? So, what is a random access interface? An array list and vector classes implements a random access interface, so that any random elements we can access with the same speed. Next, random access interface is present inside java.util package and doesn't contain any methods. So, it is also called as marker interface. The interface which does not contains any method is called as a marker interface, where the required functionality will be automatically provided by the JVM. Okay. Yes. Now we are going to see one small example. In this example, I am making use of instance of operator. So what is this instance of operator? Instance of operator is used to test whether the object is an instance of a specified type. Example, classes, subclasses, or interfaces. So what I'm going to do is, first I will create an array list object. Array list L1 is equal to new array list. Next, I'm going to create one linked list object. Linked list L2 is equal to new linked list. So first I'm going to print system.out.println L1 instance of serializable. Is the array list class implement serializable? Yes. Every collections in Java implements serializable. So this is true. Next what I'm going to do is system.out.println L2 instance of clonable. Is the linked list class implements clonable? Yes. Every collection classes implements serializable and clonable. So this is true. Next, system.out.println L1 instance of random access. So what is the type of L1? L1 is array list. Does the array list implements random access? Yes. Array list and vector classes implements random access. So this is true. Next, system.out.println L2 instance of random access. Does the linked list implements random access? No. So what is the result? The result will be false. So what are the two classes which implements random access? The random access is implemented only by array list and vector classes. Next, what about serializable and clonable? Every collection classes implements serializable and clonable interfaces. Now consider this example. Assume this is an array list and this array list has 1 crore elements. Okay. Now my requirement is I want to add an element. So al dot add in the first index and the element name is m. Okay, I want to add a element m, that is I want to add an object m in the first index. So what happens if I try to add an object in the first index? If I try to add an object in the first index, first the object will be added and the remaining objects will be shifted to the right. So how many shift operations will it perform? It will perform 1 crore shift operations. So if we perform 1 crore shift operations, definitely it will take more time for shifting. That is, shift operation is very costly. So next, my requirement is I want to remove an element. AL dot remove an element from the first index. So what happens if I try to remove an element from the first index? The element will be removed and the remaining elements will be shifted left. So how many elements will be shifted? 1 crore element will be shifted. Definitely the shift operations are very costly. It is very time consuming. So array list is the worst choice if our frequent operation is insertion or deletion in the middle or insertion or deletion in the beginning. So what is the point? Array list is the worst choice if our frequent operation is insertion or deletion in the middle or insertion or deletion in the beginning. So when array list is the best choice? So array list is the best choice if our frequent operation is retrieval operation. If our frequent operation is retrieval, then the array list is the best choice. To retrieve any elements, it will take the same time. Okay, just now we have seen to retrieve the first element and also to retrieve the 1 croreth element. It will take the same time. So in that case, the array list is the best choice. But in a case of addition or deletion in the beginning or addition of deletion in the middle, array list is the worst choice. So that is, array list is the best choice if our frequent operation is retrieval operation, because array list implements random access interface. Since array list implements random access interface, to access any elements it will take the same time. So what is point number 2? The point number 2 is array list is the worst choice if the frequent operation is insertion or deletion in the middle. So why it is the worst choice in the case of insertion or deletion in the middle? Because it involves several shift operations and the shift operations are very costly. So what is the solution for this insertion or deletion in the middle? The solution for insertion or deletion in the middle is linked list. Okay. The next implementation class is linked list. So in a linked list, how the data is stored? In a linked list, a data is stored in the form of a nodes. So this entire thing is called as a node. So a node has how many parts? Node has 3 parts. So which are those 3 parts? In a first part, it will store the address of the previous node. In the second part, it will store the data. In the third part, it will store the address of the next node. Okay. A node has 3 parts. In the first part, it will store the address of the previous node. In the second part, it will store the data. In the third part, it will store the address of the next node. So what is the underlying data structure of the linked list? The underlying data structure of the linked list is doubly linked list. So you can see here, we have 2 pointers. So one pointer is used to store the address of the next element. Another pointer is used to store the address of the previous element. So the underlying data structure of the linked list is doubly linked list. So what about the memory? Are the nodes are stored in the contiguous memory allocations? No, nodes are not stored in a contiguous memory allocations. So wherever the free memory slots are available, those memory slots will be allocated to the nodes. For example, assume the address of this node is 1001. Next, the address of this node is 2001. Next, the address of this node is 3001. Similarly, for this is 4001 and 5001. So that is, the memory for the linked list is not allocated sequentially, or not contiguous memory allocations will be allocated for the linked list. So wherever the memory allocations are free, those memory allocations will be allocated to the nodes. So we'll see the linked list. What is the first point? The underlying data structure is doubly linked list. So linked list is a collection, right? A linked list is a collection. So since it is a collection, what about the insertion order? Is it preserved? Yes, the insertion order is preserved. What about the duplicate objects? Yes, duplicate objects are allowed. So the second point is, insertion order is preserved and the duplicate objects are allowed. Next, what about the heterogeneous objects? Even the heterogeneous objects are allowed. Next, what about the null insertion? Can we insert a null into the linked list? Yes, we can insert a null into the linked list. You can see here. So this is the first element inside a linked list. So what is the address of the previous node? The address of the previous node is null. So we can store null in a linked list. So that is point number 4. Null insertion is possible. So what about serializable and clonable interface? Does the linked list class implements serializable and clonable interface? Yes. Every implementation class in a collection implements serializable and clonable. What about random access? No. Linked list does not implement random access. Random access is implemented only by array list and vector. So what is the next point? Linked list implements serializable and clonable interfaces but not random access interface. So when the linked list is the best choice? So to answer this question, first tell me when array list is the worst choice. So when exactly the array list is the worst choice? Array list is the worst choice if we have to insert or remove an element in the middle. So why array list is the worst choice if we have to insert or remove an element in the middle? Because it includes lot of shift operations. In that case, array list is the worst choice. So when linked list is the best choice? Linked list is the best choice if we want to insert or remove an element in the middle. In that case, linked list is the best choice. Say for example, I want to add an element in the first index. So L dot add of, in the first index I want to add an element m. So I want to add an object m in the first index. So how I can add an element m in the first index? Very simple. Create a node. Next, what is the next step? The next step is reassign the pointer variables. Next step is reassign the pointer variables. So the address of the m should be stored in where? Stored in this m node. Next, the address of a node should be stored in this m node. Next, the address of m should be stored in b. What next? The address of b should be stored in m. In this way, we can insert an element in between. So insert an element in the middle in the case of linked list by just reassigning the pointer variables. So is there any shift operations involved here? No, there was no shift operations. So what about the performance? The performance is very good in the case of linked list when compared to the array list. Even deletion in the case of linked list is very simple when compared to the array list. So how we can perform deletion? Very simple. What is the method? L dot remove of 3. So I want to remove a third element. What is that? 0 1 2 3. I want to remove c. So how I can remove the c? It's very simple. How we can remove? By changing the value of the pointer variables. So instead of b pointing to c, now b directly should point to d. Next, the address of d should be stored in b. In this case, we can remove an element in the middle. So was there any shift operation involved? No. The shift operation was not involved in the case of linked list. So the performance of adding an object or removing an object in the middle is very good in the case of linked list when compared to the array list. So what is the next point? The next point is linked list is best choice if our frequent operation is insertion or deletion in the middle. So when the linked list is the worst choice? When exactly the linked list is the worst choice? For example, consider here our linked list has a 1 crore elements. Our linked list has 1 crore elements. I want to access the 1 croreth element. How I can access the 1 croreth element? First I should go to the first element. Next I should traverse to the second. Next I should traverse to the third. Similarly, I should traverse 1 crore elements. So when the linked list is the worst choice? linked list is the worst choice if our frequent operation is retrieval operation. So when the linked list is the worst choice, linked list is the worst choice if our frequent operation is retrieval. If we frequently retrieving the elements, in that case the linked list is worst choice because we have to traverse from the first element to the last element. Since we are traversing from first element to the last element, definitely the traversing is time consuming in the case of linked list. But in the case of array list, if we want to access any element, we can access at the same speed. Why? Because the array list is implementing random access interfaces. So these are the points with respect to the linked list. So what is the first point? What is the underlying data structure of a linked list? The underlying data structure is W linked list. Next, what about the insertion order? Yes, the insertion order is preserved and the duplicate objects are allowed. So what about the heterogeneous objects? Yes, the heterogeneous objects are allowed. What about the null insertion? Yes, we can insert the null in the case of linked list. So next, what linked list implements? Linked list class implements serializable and clonable interfaces but not random access. Next, when the linked list is the best choice? Linked list is the best choice if our frequent operation is insertion or deletion in the middle. So when the when the linked list is the worst choice, linked list is the worst choice if our frequent operation is retrieval operations. Next, we have to see the constructor for linked list. Now we will see the constructor of linked list. So the linked list has two constructors. So what is the first constructor? The first constructor is linked list L is equal to new linked list. So what this constructor will do? This constructor will create an empty linked list object. So this constructor will create an empty linked list objects. Next, what is the second constructor? The second constructor is linked list L is equal to new linked list of collection C. So what this constructor will do? This constructor creates an equivalent linked list objects for the given collection. So given any collection, it is going to create an equivalent linked list objects. So what it's going to create? It's going to create an equivalent linked list objects for the given collection objects. Okay, give any collection object, it is going to give us an equivalent linked list objects. So these two are the constructors for linked list. Next, we have to see the methods which are applicable for linked list. Now we are going to see the linked list class specific methods. So what is the first method? The first method is add first. So to add an element in the first, the method name is add first. The second method is add last. So add last of object O. The third method is get first. Get the element from the first. Get first. Next, get last. Next, there are two more methods, remove first and remove last. So remove first and the last method is remove last. So these are the linked list class specific methods. These methods are applicable only for linked list classes. Which are those methods? Add first of object, add last of object. Next, get first. What it will get? It will get an object in the first. Next, get last. It will get an object which is there in the last. Next, remove first. It will remove the first object. Remove last. It will remove the last object. You can pause the video and you can note down these methods. So before that, so what is the return type of remove first? The return type of remove first is object. It will return an object. Okay. Next, what is the return type of remove last? The return type of remove last is object. It will remove an object and it will return that object. So now you can pause the video and you can note down these methods. Now we have to see the differences between array list and linked list. So when the array list is the best choice, that is array list is the best choice if the frequent operation is retrieval operation. In that case, array list is the best choice. Next, when the linked list is the best choice, linked list is the best choice if the frequent operation is insertion or deletion in the middle. Next, when array list is the worst choice, array list is the worst choice if the frequent operation is insertion or deletion in the middle, because internally several shift operations are performed. You know that the shift operations are very costly. Next, when the linked list is the worst choice, linked list is the worst choice if our frequent operation is a retrieval operation. Next, what about memory? In the case of array list, the elements will be stored in consecutive memory, and hence retrieval operation will become easy. So what in the case of linked list? In the case of linked list, elements will not be stored in the consecutive memory locations, and hence retrieval operation will become complex. So these are the major differences between array list and linked list. Now we are going to see an example for linked list. So first I will going to import java.util.star. Next I am going to create a class. I will name this class as linked list demo. Class linked list demo. Next, within this class I am going to define a main method, public static void main string array args. Next, within this main method I should create a linked list. So how to create a linked list? Linked list L is equal to new linked list, that is using the constructor linked list L is equal to new linked list. So using a constructor we can create a linked list. So what this constructor is going to create? This constructor is going to create an empty linked list object. Next, I want to add an element inside this linked list. So what is the method to add? There are several methods like add, add first and add last. So I will use add method, l.add. So where this add method is defined? This add method is defined inside collection interface. So the method which is defined inside collection interface is available to all the classes. So, okay, these are like the global methods. L.add of, I will add CMR. Next, I am going to add L.add of 6666. Next, I am going to add L.add of, I am going to add null. Next, so what about this null? This null is a data, okay? This is not a value of a pointer. This null is a data. Next, I am going to add L.add of CMR. Yes. In this statement, so what is the content of the linked list? In this particular line, the content of the linked list is, the first content is CMR, next 6666, next null, next CMR. Okay. Is the insertion order is preserved? Yes, the insertion order is preserved. Is the duplicate values are allowed? Yes, the duplicate values are allowed. CMR is duplicated, you can see it is repeating twice. Next, what about the heterogeneous objects? Yes, the heterogeneous objects are allowed. Here I am passing string and here I am passing integer value. Next, is the null insertion is possible? Yes, the null insertion is possible in the case of linked list. Next what I am going to do is, I am going to replace. So what is the method for replace? The method for replace is set. I am going to replace the first element, that is 0, with SOET. That is, I am going to replace CMR with SOET. Okay. At this particular line, what are the contents of our linked list? The contents are SOET, because we are replacing CMR with SOET. Set means replace, okay? SOET comma 6666 comma null comma CMR. Next I am going to add L.add. Where I am going to add? I am going to add at the first position. First position means 0 comma, what I am going to add is, I am going to add CSC. Okay. Now at this particular line, what is the content of our linked list? The contents are CSC comma SOET comma 6666 comma null, comma, CMR. So these are the contents of our linked list. Next, I want to remove an element at the last. So what is the last element? The last element is CMR. I want to remove an element at the last. So what is the method to remove an element at the last? The method name is remove last. So L dot remove last of, we are no need to pass anything because remove last means it automatically removes the last element. Now at this particular line, what are the contents of the linked list? CSC, comma, SOET, comma, 6666, comma, null, and this CMR has been removed. Next, I want to add an element at the beginning. So what is the method to add an element at the beginning? Add first. So L dot add first of, I want to pass an element, so I will pass IT. Okay. Next, at this particular line, what is the content of our linked list? The contents are IT, comma, CSC, comma, SOET, comma, 6666, comma, null. Next, I am going to print this linked list. So how to print the linked list? System dot out dot println of L. Okay, this is going to print the linked list. Save the program, compile this. So how to compile? Java C linked list demo dot java. Next, ignore those warnings. Okay. Next, java space linked list demo. So now what will be the output? The output is ITCSC SOET 6666, comma, null. That is ITCSC SOET 6666, comma, null. So what this square bracket indicates? This square bracket indicates this is a collection. Okay. The square bracket indicates this is a collection and the contents are this, that is ITCSC SOET 6666 and null. So those are the objects. If you have any doubts, please contact me.